My today's topic of presentation is longest common subsequence problem. This problem is very popular in actually computational biology, where we wish to find out the length of the longest common subsequence and even the sequence also. So here is outline of the presentation, and first we will talk about dynamic programming, and then we will talk about differences between dynamic programming and divide and conquer approach, because both approaches are based on dividing the problem into parts and then solving each problem. So we'll find out the difference between DP and dynamic divide and conquer approach. So one of the problem in dynamic programming is longest common subsequence, right? LCS, longest common subsequence problem. And then we will try to solve the LCS using dynamic programming approach. Then we will analyze the algorithm. So what is dynamic programming actually? As the name suggests, it is not using programming terminology. It is just approach which is solving the problem by dividing the problem into parts, and here one problem, this problem, if you divide into parts, so sub problem, they are used to solve the above problem. So this actually, when the solution can be recursively described in terms of solution to sub problem. Actually here in dynamic programming, main solution is described in the terms of solution to the sub problem actually. And once suppose there is one problem and we divide into various parts, then when we solve this, then this can be used to solve another problem, and then finally this can be solved to another problem. So where we in this approach we divide the problem into sub problem, and then and sub problems over here are actually not independent, they are dependent. So this algorithm finds solution to sub problem and store them in a memory for later use. So this is more efficient than brute force method which solve the same sub problem over and over again. So here is the difference between dynamic and divide and conquer. So divide and conquer method, 3 steps at each level of the recursion. First one, we divide the problem into the number of sub problems. Then we conquer the sub problem by solving them recursively, and then combine the solution to sub problem into the solution of original problem. Here in problems may not be like dependent, right? Suppose in the merge sort, you see, suppose in the merge sort, if we divide a problem into half this side and solve this left part and solve this left part, where this part is not depending on this part actually. Yeah, this can be solved independently and this can be solved independently, and later on solution to this problem and solution to this problem can be combined to give the solution to overall problems. So while in dynamic programming it has 4 steps of the So first it involves sequence of 4 steps. This one first it characterize the structure of an optimal solution, how solution will look like, and second one, once we characterize the structure of an optimal solution, will recursively define the value of optimal solution, and after recursively defining the value of an optimal solution, we compute the value of optimal solution in a bottom-up approach. And then final step of the dynamic programming is construct an optimal solution from the computed information, right? So it does not work on the it does more work on the sub problem actually, and hence has more time consumption. It solves sub problem only once and then is stored in the table. So here once we divide the problem into sub problem, we are solving the sub problem only once and we store into the table, and that value can be used for further computation. That means sub problems are dependent actually. So it is following top down approach, it is a bottom up approach actually. So in these sub problems are independent of each other. We don't actually like here in the merge sort, this is independent, this is independent. But in this dynamic programming, sub problems are highly dependent. So there are many like algorithm which can be solved by dynamic programming, like matrix chain multiplication, and then longest common subsequence, optimal structure of binary search tree, optimal BST, and one very good problem is knapsack problem. So many problems which can be solved by the dynamic programming. This one like here, binary search and quick sort, merge sort, many algorithms are there in this category. Even like computing the matrix multiplication by Strassen's matrix multiplication method. So this is also can be solved by the dynamic divide and conquer method. So as I said that there are 4 steps of dynamic programming. First one will characterize structure of an optimal solution, and then recursively define the value of an optimal solution, and after recursively defining the value of an optimal solution, will compute the value of an optimal solution typically in a bottom up fashion. We don't require in top down fashion. So then 4th step, after computing the value of an optimal solution, will construct an optimal solution from step number 3. So this first problem of this dynamic programming, we can think of solving longest common subsequence LCS problem using dynamic programming. Look at here. Why this problem is very important from algorithmic point of view. This is very popular in computational biology, where we want to find out similar DNA, similar RNA, that how two DNAs are similar actually. So this is very popular. Look at here, like for example, DNA is basically is defined on the alphabet ACGT, where A stand for adenine, C stand for cytosine, and G stand for guanine, and T stand for thymine. So that means DNA is any DNA sequence is actually is alpha like string over ACGT. Any DNA sequence is string over ACGT. For example, consider one DNA. This is DNA of any living organism or anybody, and the DNA of another organism is this. Question is that whether to check whether both DNAs are matching or not. It can that is the problem of the longest common. How long this DNA is matching, how much similar both DNA are actually. So if we are solving this problem by brute force approach, we have to solve one by one, we have to compare one by one. But in LCS dynamic programming, we will not calculate one by one. We'll use dynamic programming to find out whether how long this DNA S2 is matching in this DNA S1. So as we know that this is longest common subsequence. So let us understand like this is a sequence. If you see here, if you just write down 1, 2, 3, 4, so this sequence can be treated as 1, 2, 3, 4 in terms of the alphabet, right? So longest common subsequence, first one we will find out this what meaning of subsequence, then we'll find out what is meaning of common subsequence, and then we'll talk about what is longest common subsequence. So actually let us define subsequence. Suppose we have any sequence like x, which is x1 to xm, and another sequence, let's say z, z1 to zk. And we are saying that this z is a subsequence of x, right? If there exists a strictly increasing sequence of the indices such that for all j we have xij equal to zj. For example, consider this sequence BCDB, and there is another sub sequence ABCD. If we look at here, BCDB, B is found over here, BC and then DB, BCDB, increasing order. So JDJ subsequence of X actually. JDJ subsequence of X, because entire Z should be found in X with increasing order of indices like B. B is found at index number 2. So C must be found at higher index. So C is found at 3. And then D is found at the next index 5. And then B is found at 7. So that means we can get this sequence like of increasing indices 2, 3, 5 and 7 such that Z is found in X. That means this Z is found at this indices 2, 3, 5 and 7. So that means Z is a subsequence. So now question is that what is common subsequence? So common subsequence in this situation, given two subsequences, right? Let's say X and Y. Now we say that a sequence Z is a common subsequence of X and Y if Z is a subsequence of both X and Y. Look at here. Consider this X is A, B, C, B, D, A, B and Y is another sequence actual. See, so if we talk about sequence BCA, yes, let us see whether BCA is common between both or not. Yes, this is B and then C and then A. Yes, this is found at index number 2, 3, 6. And BCA, B is here and C is here. And this A can be taken or this A can be taken, there is no problem. So yes, that means BCA is a common subsequence of both X and Y. On the other hand, if we talk about DB, let's say, suppose if we talk about sequence DB, DB is found over here, but DB is also found over here. That means DB is also a subsequence of both X and Y. But on the other hand, if you talk about A and on the other hand, if you talk about BA, yes, BA is also found over here. BA is also found over here. That means this is also common between X and Y. For example, let us consider X is A, C, D and E and Y is, let's say, B and D and G and let's say X. So now not X, let's say H. So if we talk about whether DE is a common subsequence between X and Y, question is no. Answer is no, because DE is not common between both X and Y. DE is found over here, but D is found over here, there is no A. So this DE is not common subsequence of X and Y. So now question is longest common subsequence. So LCS means that it should be common as well as it should be the longest one also, right? So you see here, like BCA was subsequence BCA, but BCA is not longest, because we can say that BCBA and BCBA is the longest, right? Because its length is 4 and BCA length was 3. So that means it is not longest. This is the longest. So it is not necessary that longest common subsequence is only one. It is not unique, because we can get another 4 length subsequence, let's say BDAB, 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 this is also common, and BDAB, this is also common. That means this is the longest one also. This is also having 4 length. This is also having 4 length, right? So that means that LCS is not unique. We may get more LCS of the same length. However, length of the LCS is unique. We cannot get more than 4 length LCS from this X and Y. So, what is objective of this presentation is that LCS, our objective is to find out LCS between 2 sequences, and then later on we will find out any LCS which has this kind of length, maximum length. So I said that, okay, if we say X and Y, look at here, this is B and this is C, B, C, A, that means length of the LCS is 4. We can see that, okay, so LCS, which we call it at Z, this is B, C and B and A. This is LCS of the sequences. Yeah. So as I said that there are 4 steps of the dynamic programming. Number 1 is characterize the structure of the solution. Second one, define the recursive solution. And third one is design algorithm to find out the value of optimal solution. And then 4th step is the find out the solution. So let us understand how to characterize the structure of LCS. Step number 1. So suppose X is this sequence and Y is this sequence, and consider Z to be any LCS of both X and Y. Okay. So we can see that there are 3 cases to get the LCS, and suppose this guy and this guy, if they are equal, and they are also definitely if they are equal, then that means that they are going to contribute in the LCS, right? So if they are equal, that means they are going to contribute into LCS. Then if we can say that this ZK is also equal to this, that means the remaining values x1 to xm minus 1 and y1 to yn minus 1 is basically going to be LCS of ZK minus 1. That is very simple. So ZK minus 1 is LCS of this and this. Yeah, this guy ZK minus 1 is LCS because both are matching. So we are not going to consider them further. So this y m minus 1, n minus 1, and then x m minus 1, x m minus 1. Basically, and now this is ZK minus 1. So we are looking for Z1 to K minus 1 as LCS of XM minus 1 and YN minus 1. Case number 2, suppose that if both end points are not matching. So if both end points are not matching, so then we have 2 sub cases. So if both end points are not matching, so we say that if ZK is not equal to XM, that means if this guy is not equal to this, that means XM is out of the LCS. It is no more going to contribute. So what will happen? Then entire Z will, since it is not in the LCS, entire Z is going to be LCS of 1 to XM minus 1 and this Y complete, right? Yeah. If same situation, if end points are not equal, that means XM is not equal to YN and ZK is supposed to is not equal to YN. So that means this is ruled out to be LCS. It is not going to be LCS. So what will happen? So Z will be LCS of actually complete X and Y1 to N minus 1. That is it. Simple. So this is the structure of an optimal solution. So after getting a structure of an optimal solution, what we are going to find out? We are going to develop the recursive solution to solve the problem. So suppose xi and yj be the prefixes of x and y of length I and j respectively. And we build a table Cij to be the length of this up to xi and up to yj. then the length of LCS will be CMN, where M is the length of first sequence and N is the length of second sequence. So how we can define this Cij? Look at here, if both are equal, if ith point xi and yj are equal, that means we are not in, we got one length of the LCS, and then remaining computation will be done from Ci minus 1 and j minus 1. On the other hand, if they are not equal, that means xi is not equal to yj. What will happen? There are two cases, right? So it will be maximum of Cij minus 1, where this yj was not equal. So I complete and then j minus 1, or Ci minus 1 and j. So, and what we are going to start with, if I and j equal, that means we are talking about empty substring of x and y, then definitely C0, 0 will be 0, because there is no matching between 0 and 0. So this is always empty. And suppose if first value is 0, that means this is empty subsequence, and whatever is here, we don't care, because if one is empty, other one is even any number of sequences, it is always going to be 0, because there is no matching between both. Same thing here, Cij, and even I, if it is j is 0, whatever is value of I, it is going to be 0. So, so we have three cases now. First case is actually when both are equal. So what we did xi minus 1 plus y minus 1, like Ci minus 1, j minus 1 plus 1, because we got one length actually, because both are matching. So that is how it is being done. And in the second case, when both are not equal, so it will be either this or this, and whoever is giving maximum result, we will take that into the consideration. So this is the actually algorithm LCS length x and y, where we assume that M is the length of the x first string, N is length of the second. Let us set I0 as 0 for all I from 1 to M. And same thing 0j as 0, because there is no matching between this and this. It is empty string, and this is up to the length of j. So in this situation, we run a loop up to 1 to m for I from 1 to m and j from 1 to n. If both are matching, that means end sequences are matching, like here x1 up to and so on xm, and y is y1 up to and so on yn. This situation is that when both are equal, right? In both are equal, so definitely we are interested in LCS of this and LCS of this, because we got it, so this is +1. Otherwise, if this is not equal, that means either this is LCS of this and complete, or this is LCS of complete or half. So then after this computation, we are going to return this value. Let's see how it is working. So consider this x ABCB and this y is BDCA. If you look at here, we are already having like what is the longest common subsequence. We can see BC like BCB here. Look at here class, BCB, right? This is BCB and this complete. That means we already know in advance that length of the LCS is 3. Let's see how algorithm will compute. So this one is based on the tabular representation, right? So if we understand it very well, this is BDCAB, this BDCAB, right? Its length is 5, so we design a table of 6 length. Same thing, x is ABCA, ABCB, we can place either x over here or y over here. There is no problem. Anyone can be placed anywhere. Yeah. So you see here, x is ABCB, its length is 4, and y length is 5. That's why I'm saying that there are 6 columns and there are 5 rows, right? So first step, make this row as 0 and this column as 0, because this C0J for j from 1 to n, so this will be 0, all 0. First do this, all 0, yes, and then for all rows make the 0th column as 0, because there is no matching of the subsequences, right? Yeah, after doing this, what we are going to do actually, we will start from first one. Here, look at here, we'll compare them, A and B. Are they equal? No. If they are not equal, we are going to copy this over here. We can copy this over here also in case of if they are not equal, anyone which is maximum. Now 0, 0, and since they are not equal, this is 0, this is 0. So both are equal. In case of equality, we can either copy it over here or we can copy it over here. So let's copy this horizontal value over here. Yes. So this is how, this is maximum. So we will copy it over here. We assume that both are same. In the same situation, in the same situation, here D and A, they are not equal, no problem. Again A and C, they are not equal, yes. Now look at here, A and A are equal. In case of equality, we will find out the diagonal value, right? So diagonal value is 0 and 0 plus 1, that will be the value. This is the diagonal value and plus 1. Look at here, class. Yes. Yeah. And again, if you go here, B and A, they are not equal. A and B, there is no match. So anyone which is maximum, this is like maximum, so we write it over here. Yeah. So let's start with next row. Yeah, both are matching. Look at here, B and B, there is a match. So if there is a match, we will just write it over here by increasing its value to 1. So you see here, this is 1. Same thing over here, again B and D not matches, so this is maximum, we will copy it over here. B and C not matches, this is maximum, we will copy it over here. And then B and A, there is no match, we will copy it over here. Yes. So both are equal, so anyone can be copied. Let's see, let's copy it over here. So now last one, if you look at here, B and B, there is a match. If there is a match, we will copy this guy over here, right? By increasing its value to 1. So this is 1 plus 1 become 2 because there is a match. Yeah, this is match. So same thing we can start from C. Look at here, C and B, there is no match. Which one is maximum? This is 1. This is maximum. We will copy it over here, right? And then this one, anyone, both are same. So in the case of equality, we are copying this horizontal one. We can copy the vertical one also. There is no problem. So same here now, class. C and C both are same. In this situation, what we will do, situation is like this is 1 plus 1 become 2. Because in case of equality, C is not equal to A, yes. So we are going to copy this. Same thing, C is not equal to B, yes, we are going to copy this. That is it. So now B and B is equal now. So this is 0 and this become 1 because we are interested in vertical diagonal one. B is not equal to D, it is going to be copied. Same thing, B is not equal to C, it is going to be copied because this is higher than this, anyone which is giving the maximum. And then B and A not equal, yes, anyone, both are equal, we copy it over here. Now last one, B and B, B and B, they are matching, there is match between B and B. So what will happen here, this is 2 and 2 plus 1 become 3, that is it. This is the longest, this is the length of the LCS. So that means you have seen that length of LCS was 3. So this value, whatever value is sitting over here, this will give you the length of LCS, not LCS length. So you see here, so now we have computed the length of the LCS. Question is that how to get that LCS? There are two methods. We can do it separately, or we can solve the, while solving this, we can also find out the LCS by using by incorporating fourth step in the table itself. So far we have just found the length of LCS but not LCS itself. We want to modify this algorithm to make output longest common subsequence of x and y. How it is going to be calculated? This was step number 4. If you look at here, Cij actually is either depending on this or this or this. Cij is depending on 3 values, right? So, and suppose that if we have this situation and this is going to be computed from here, so that means Cij was computed from here. So we can store this value and we can store the direction of the value also here. So look at here, this is how it is being done, because this guy, if you look at here, it was computed from here. So you can go here, and again this was computed from here, we can go here, this was computed from here, we can go here, this can go. So if we start by doing this, this is diagonal. So if any time we are going to the diagonal one, we just store these value, highlight them, right, and this one, and write it over here. See, anytime we are going horizontally, we will not find out the LCS, we will not get LCS. And now we are changing this direction. So anywhere like this, changing the direction, that means this and this, they are going to be part of LCS. From where you are changing, they going to the diagonal side, you just highlight them, and that will contribute to the length of the LCS. So we will just print it here. Again, we are not interested in this, as it is going to, there is no match. Now we are going to the diagonal side. That means this guy and this guy, they are going to be the part of LCS. So that is in reverse order. We have printed BCB. This is BCB, we have printed from here. And in straight order also, we can say that this BCB is also going to be part of the LCS. Yes. So this is one of the method we can get LCS by this. While we can also get LCS while doing the computation. For example, consider this example, x and y. So same situation we are going to do here. Look at here, when we start from this one is 0 and this complete 0 in the first step. Now A and B no match. So since we are copying here, you can copy here also. In case of equality, you can copy anything. So we will put a direction of the arrow over here. Same thing, A and D, no problem, A and D. We are putting arrow, like see, A and A, there was match. So you are copying from here. So put a direction so that there should be no extra work. Similarly here, you see here A and B, there is a match, right? No match. B and B, no match. So, and you are copying from here, so you have to go by this direction. And A and A, there was match, you are copied from here, copying from here, so you have to go by this direction. So we will introduce the direction arrow while we are computing here. So by doing this, we can say that we are coming over here, right? So this direction arrow will guide you whether which direction you are going. Like see, if you are computing 4, that means length of LCS of x and y is actually 4. This is very, very clear that our length is 4. So if you want to get what is that sequence, you have to start from here and go direct up that means this is not LCS. If you go here, this is here. So that means anytime you are going to the diagonal, this is going to be the part of LCS. This is going to be part of LCS. Same thing here, go here, no, it is not going to be. If you come here and row and then column, this is going to be LCS. Go here, horizontal, it is not going. So we have to go like this. This is part of LCS. Come now here. This is not going to be part. Anytime you are going in this direction, this is part of the LCS. So your part LCS is ABCBA. No, this is not. This is the part. This is not going to be LCS. Only this is the LCS. So BCBA, BCBA. So this is easy, and you know here actually all this this value is always giving you some information. This is the beauty of LC, like beauty of this dynamic programming. Suppose if you are interested in over here, start from here, and now this is BDCA sequence. See, BDCA sequence. If we start from here, we don't know this value. And then this is another sequence ABCBDA, ABCBDA, right? This is here because we are starting ABCBDA, ABCBDA, and this one is BDCA. So you see, if you want to get LCS of this, you start from here. That means A is matching, and A is matching here. Again go here, vertical, we are not interested. We are interested over here, and that means then C and then C, then C and C, right? C is here, and then here is B and B, right? That means BCA is common subsequence of this and this. So this is very informative. From anywhere you can start, is not necessary. You can start from here, like see, if you have ABCB, you start from here, and then BDC, you start from here. That means C and B. BC is the only LCS of this sequence. You can start from anywhere to get the LCS of string. So what is its running time? Let us analyze it. We have seen that the LCS algorithm calculate the value of each entry of array CMN, right? So actually its running time is big O of M times N, where M is number of rows and or length of first sequence, and N is number of column, length of the second sequence, right? So this is all about. Thank you.